Welcome to another episode of We Should Code. Today we're going to be talking about math and coding. Okay, so what parts of mathematics are necessary for you to be a coder, programmer, what have you, and which are just kind of there for grading purposes. Okay, so all in all, you have to have basic math. Okay, because that's where you use your operators. You have to have a great understanding of division, addition, subtraction, multiplication, understanding equivalence operators. Okay, so you got to have an understanding of basic math in general for all coding purposes. Okay, there's no way around that. So, got to have that. And most people who are interested in programming, you come to it because you have a foundation in basic mathematics where you're comfortable enough with it that you're not completely turned off by programming when you see it. So if you're not a person who can do the basic math, you're not going to end up pursuing programming outright. So that's implied, okay? Um, Next, you have your Calculus 1 and 2. Now, these are probably the introductory courses that you're going to first take in college or even in high school prior to you being able to qualify for some of those college or AP programming courses. Um, and it comes into play to some extent with coding, but for the most part, it strictly is a test for whether you can learn principles, complex principles that may be used in some formulations, although I haven't really seen any calculus formulations that are used in the 90% of coding, what you'll be doing, like um, arranging like servers, database, basically back end stuff, front end stuff. None of the functions really require you to do any calculus at all. So it's primarily used as kind of a weeding out by schools. Okay, so you'll have to go through calculus 1 and 2, and you'll see what I mean about how they use it to weed out people who are otherwise just not going to make it through the harder classes. So the one that fits mostly with coding that you'll find yourself into is linear algebra, and that's primarily because you'll be introduced to arrays and matrices, which is very similar to the coding with like I mentioned, arrays, array lists, kind of falls right in with the understanding of that. So you can kind of see the functionality of how linear algebra kind of can play into that. That's really it. The rest of it's more or less a waste. Okay. But the matrices, um, the vectors, all those things sort of play into becoming a master at coding because you have to understand that in order to kind of take the big picture and make it into a solution and be able to come to or arrive at solutions in your programming. So I would say linear algebra is probably the closest you have to being able to solve real programming problems. So it's a class to sort of focus in on and do well in. Okay. Statistics also plays into this. Now you think about things like people who design dating apps, data science in general, AI, machine learning, all those things look at data and try to manipulate data and put everything in the form of a statistic or some kind of visual display, charts, what have you, pie charts. So you're displaying numbers in a way that makes sense and you're applying it to how many students in the room are taking XY class. Um, Everything from population in a city, how likely is this population to grow to a certain number by year 2050? All those things use statistics and the basic equations related to that can be directly applied to actual apps and let's say for example BMI, all those things are basically numbers that are plugged in to already established formulas, and that sort of plays into what statistics is. And so that's another important class you have in addition to linear algebra. So I would do well with that and make sure you take that or have a solid background in that as well. Okay. So one of the last few classes is discrete mathematics. That's probably the next highest on the list of linear algebra and statistics as far as being directly plugged into coding. You have your set theory, graph theory, all those, even the logic plays into directly linked to coding. Okay, so you really can't do without discrete mathematics. So that's the class I would just go ahead and start learning the basics of now when you're in high school, college, and try to make sure you have a good understanding, because once you take the college level courses, you're going to need that in order to do pretty well with the programming courses that follow. Um, Everything from the sequences, the series, all those things play into arrays, array lists. Um, so you have to be at a great foundation with discrete mathematics from the jump. So in particular, graph theory, set theory, all those are directly tied into coding. So there's really no way around it. So you got to know discrete mathematics. Then lastly, part of discrete mathematics is graph theory, but you'll see that in your algorithms and data structures. So it's a direct link. Some classes or some colleges may offer that as a separate class altogether because it is a large topic. So that's another thing that you have to come to understand, because that does plug into coding almost directly. Okay, so that's it for the most part in a nutshell. Those are the biggest classes that you're going to take when you're entering the late high school, early college years. Are going to be fundamental to making sure that you can be the strongest programmer you can be. As always, please like and subscribe to our channel for more content. Jets always needs more friends, and we'll be up with more content related strictly to coding in the weeks to come. Take care.